gentlemen, and everybody else, welcome to our second to last section in Chapter 10, our section on the power theorems. Power theorems are theorems dealing with the lengths of segments in and about circles. Again, these are power theorems. These have to deal with segments, lengths of sides. Let's go on to our first power theorem. Again, all these power theorems are theorems. They are proven. We're not going to do that right now. But again, I will maybe do one of these in class. These all have to do with the theorems. Proofs have to do with triangles. The first one is the easiest of their three power theorems, the chord power theorem. That says if I have two chords, one in red and one in blue, if I chop these chords up, like for example in blue, I'm going to call this guy A, and this piece here B. And in red now, I'm going to call this piece C, and this lower piece D. The chord power theorem says that A times B is equal to C times D. That is the chord power theorem. So again, if you look right here, this is going to say that X times W is equal to Y times C. So if we're looking at this problem right now, okay, find AB. So I'm looking for this length right here. I know that 2 times 15 is equal to 10 times, let's call this puppy X, 10x. So 2 times 15 is 30, is equal to 10x. X must be 3. So the length of AB is 3. The second power theorem is the secant tangent power theorem, because again, we have a secant. The secant I'm going to write here in blue. Here's my secant. Okay? And I also have a tangent. I'm going to do that one in red. Okay? The tangent theorem only has one piece. We'll call this guy X. I'm going to call the outside part, we call that the external part. I'm going to get a different color here. The external part of my tangent. So I'm going to call this external part right here, the external part of my secant, I'm going to call that Y. And then I'm going to call my whole tangent, the whole puppy. We'll do that in black. The whole puppy right here, we're going to call Z. What this power theorem says is that X times X, or if you prefer, X squared, is going to equal Y, the outside part, times the whole thing, Z. So in other words, let's look at that one more time. The tangent secant power theorem says it's the tangent p squared, so let's call this the tan p squared. So that piece squared times the entire secant, we'll do that in purple. The entire secant times just the outside part, do that in blue. So the entire secant in blue, the entire secant in purple times tangent squared, the outside part of the tangent. One common mistake that people make on this is they call, this piece A and this piece B, and they just do A times B. No, you got to do more than A times B. It's going to be A times A plus B. Okay, so make sure you're doing the outside part times the whole thing. So looking at this problem right down here, okay, circle P has a radius of 5, so this piece is 5, which means also this piece is 5, which means my entire inside piece is 10. So now we are going to do the outside piece. We'll do that in purple. The outside piece is X, that's X squared, times, or is equal to the outside piece, we'll do that in green, that's 5, times the entire secant piece, which is 5 plus 10, which is 15. So X squared is equal to 5 times 15, which is 75. X is going to equal root 75. and using what we know about radicals, inside the 75, that's 25 times 3. I can pull that 25 out, and he becomes a 5. So this now equals 5 root 3. Okay, the third power theorem is the secant power theorem. Notice I have two secants. I have the green guy, I got the blue guy, and this theorem says, very similar to the last one, I take the outside piece, A, times the whole tangent, we'll call this whole thing B, so that's A times B, is equal to the outside piece of the other one, we'll call that C, times the whole other tangent, I'm choosing a color here, black, whoop, that whole thing, we'll call that guy D, so it's A times B is equal to C times D. Again, do not fall for the mistake, okay? If, for example, this piece is 7 and this piece is 5, when I do the bottom piece, it's not going to be 5 times 7. No, that's wrong. It's really going to be 5 times 5 plus 7. And that's how we got to make sure it's the outside part times the whole thing. On both sides. So again, when we do this, it's the external part times the entire thing is equal to the external part times the entire thing. Or BC times AC is equal to CD times CE. Okay? So, looking at this guy right here, using my secant power theorem, I know that 4 times the whole thing, again, don't fall for that trap, it's not 4 times x, it's 4 times 4 plus x is equal to 6 times 15. Again, you got to add those up. Now we're just going to solve for x. 4 times 4 I'm going to distribute is 16 plus 4x is equal to 6 times 15. Don't tell me that's going to be 90. Give myself a little bit of room here. 4x, I'm going to subtract the 16 from both sides. This would be 74. Divide by 4. Divide by 4. And half of 74 is 37. Half of 37 is 18.5. X is going to equal 18.5. Okay, let's do these two. We'll do the first one together. You'll do the second one on your own. Looking right here, we got looks like a chord power theorem. So I know that 8 times x is equal to, so here's my 8 times x is equal to quattro times quattro, 4 times 4. So now 8 times x is 8x is equal to 16. I think x is going to be dose. That one wasn't too bad. Looking at this guy here on the right, now let's actually do this one together. The algebra is a little bit interesting. It is a chord power theorem. The actual geometry part's relatively easy. I have x plus 9 times x. Okay, so I have x times x plus 9 is going to equal pieces of the other guy, so that's x plus 3 times x plus 4. Mr. Kerber, do you going to do some algebra? Yes, you do. X plus 3 times x plus 4. Okay, so on the left side now I'm going to distribute my x's. I got x squared plus 9x is equal, here I need to FOIL. X squared plus 3x plus 4x plus 12. That then becomes x squared plus 7x plus 12. But before I even worry about that, let's do some canceling. Do we agree the x squareds can go? So I now have 9x is equal to 7x plus 12. I'm going to subtract 7x from both sides. Minus 7x minus 7x. 2x is equal to 12. Therefore, x equals 6. Okay, these two are secant tangent power theorems. So again, to remind us, we know that in the tangent part, I'm going to take this piece and square it. So I have 6 squared is equal to the outside part of my secant times the whole puppy. So that, I covered that up. Is that a 4? So that's going to be 6 squared is equal to 4 times the whole thing, 4 plus x. So now I have 6 squared is 36 is equal, let's distribute. 16 plus 4x. Do a little bit of algebra now. I'm going to subtract my 16, subtract my 16. 4x is equal to 20. So x is equal to 5. In this other guy, we got some decimals. That looks a little bit frightening, but let's see what happens. Okay, I'm going to do 7.5 squared. That's the outside. Oh, wrong. This is actually, take that back. My fault, my fault. This looks like a secant tangent, but I'm looking closely now. It's a secant power theorem. So I know I'm going to do 5, the outside part, times the whole thing. So I have 5 times 5 plus x is equal to the outside part, 7.5, times the whole puppy. Well, 7.5 plus 4.5 is going to be 12. Doing a little algebra now. 5 times 5 is 25, plus 5x. 7.5 times 12, 7 times 12 is 84. Half of 12 is 6. That's going to be 90. Or you can whip out your little mini calcs. Okay, I'm going to subtract 25 from both sides. And I'm going to get 5x is equal to 65. X is equal to 13. Okay? You guys go ahead and try these last two, and actually, you know what? Don't try this guy because it comes out in a quadratic equation, which is pretty yucky. So just try that last one. Okay, for this last one, you should have got x is equal to 13, and we get that by using our secant power theorem. On the top one, I know that 4 times 12, the whole thing. So it's the outside part times the whole thing. So 4 times 12 is equal to the outside part 3 times the whole thing, which is 3 plus x. Again, don't fall for that saying that's just 3 times x. It's 3 times x plus 3. You got to do the whole thing. Now we're just doing some algebra 1, folks. 4 times 12 is 48. 3 times x plus 3 is 3x plus 9. I'm going to minus 9 from both sides, divide by 3 on both sides, and I do get x is equal to 13. You have a great day.